Here is point-slope form of line equations. So the general formula for the point-slope form of an equation of a line is y minus y1 equals mx minus x1. I like to tell my students that the y that comes first and the x that comes first that do not have little subscripts will stay as x and y. You will not be replacing the x and the y that I have in purple with any number. However, the x1 that has a little subscript and the y1 will be replaced with actual numbers in the questions that you will see. So x1 and y1 are the coordinates of a point. M should sound familiar to you. You've seen this before, and m is going to be the slope. So an example of equation given in point-slope form is y minus 7 equals 1/2 x minus 2. So let's compare this equation with the colorful one I have on the left here. As you see, the x and the y were not replaced with any numbers. They're staying as x and y. The 2 that comes in the back of the parentheses here is our x1. So x1 is 2. The 7 that comes after the minus sign, that comes after the y, is your y1. M, which is the slope, is the number in front of the parentheses, and that is your 1/2. Now, sometimes students ask me, why am I saying that x1 is 2 and not a negative 2? Because it looks like it has that negative sign in front of it. And the same with the 7. Notice I did not say that 7 was negative. I did not say that 2 was negative. The reason for that is because of the formula. In your formula, each x1 and y1 have a negative sign. So if you see a negative sign in the actual equation, that negative sign belongs to the formula. It does not belong to your actual 7 or 2. That's why we say that 2 is positive and 7 is positive. So essentially, x1 is everything that comes after the negative sign, and y1 is everything that comes after the negative sign. Let's look at a similar example. Y plus 7 equals negative 1/2 x plus 1. Now let's start with the slope. Slope m comes before the parentheses. So m here is negative 1/2, and that is your slope. I'm going to write on the left here. M is negative 1/2. Now let's be very careful with our x1 and our y1. So x1 is whatever comes in the back after the minus that we are used to seeing in the formula. So we know there should be minus here from the formula. But somehow our 1 is appearing positive. The only way for that 1 to turn positive, as we see it, it has a plus symbol in front of it, is for the 1 to have its own negative. So one negative is from the formula, and the second negative belongs to the 1. And if you have a negative followed by a negative, that becomes a plus sign, and that's what you see appearing in the final product. So your 1 is actually negative, and that is your x1. So x1 is negative 1. Very similar with the 7. So 7 appears positive. However, we know the formula has a negative there. It's this negative right here. But somehow 7 ended up with the positive sign, and the only way for it to end up with the positive sign is to have its own negative, and that negative communicates with the negative from the formula to become a plus. So 7, which is your y1, is actually negative as well. So here's an example that asks you to graph a line that's given in point slope form. Y minus y1 equals mx minus x1 on the coordinate plane. I will first identify the same three pieces of information as we did in the previous two examples, and then I'll show you how to use that information to position the line on the coordinate plane. So first of all, let's determine our m, which is the slope. M comes before the parentheses, it's 2/3, and that is your rise over run. So we will be going up 2 and 3 to the right. The line will be rising from left to right since the slope is positive. Now let's determine your x1. Well, x1 is the number that comes after the negative inside of the parentheses, and that x1 is actually a positive 1. y1 is the number that comes after the negative. Now our number here appears as positive 3, and remember it's the same idea as before. The only way for that 3 to turn positive is for it to have its own negative, because one negative comes from the formula, and then for that negative to magically become positive, it needs to be followed by a negative that belongs to the 3. So y1 is actually a negative 3. Now what these two numbers are is nothing but a point with coordinates 1, -3. To graph this line, you will first position the point 1, -3 on the picture. So 1, -3 is located right here. From this point, using your slope, 2/3, you will go 2 up, 3 to the right. So 2 up, 3 to the right. Wherever you end up is your second point, and you just connect the two and you're done. Write an equation in point slope form. So this is the point slope form, and in slope intercept form. And this is your slope intercept form. We are familiar with this form for a line that passes through a point that is given to you with coordinates -8, 6, and has a slope of 4. We will first use the point slope formula to plug in all of the information that's given to us, and then we will go from that formula to the slope intercept form by simply rearranging the things in the equation. So the problem tells us that we have a point -8, 6. -8 is your x1 and 6 is your y1. So those numbers will be replacing the x1 and the y1. The slope that's given is 4. So that 4 will go in place of m in your point slope form. And that will be it for the first part. So here we go. We got y minus and then y1. Now our y1 is 6, so -6. Then my equal sign, followed by m, which is 4, followed by a set of parentheses, x minus, followed by x1. Now our x1 is -8. So notice I am writing two negatives for the time being. One negative comes from the formula. I'm going to highlight it again in the formula. It's this negative here. The second negative belongs to the 8 itself. The 8 was given to us as a negative number. That's why you ended up with two negatives in front of the 8. We will clean it up and make it +8. So here is y minus 6 equals 4x + 8. And that's it. That answers the point slope form part of the question. Now we will use this form to make it look like this, like our slope intercept form. So I will keep the same equation, y minus 6 equals 4x + 8, and I will try to make it look like this. So clearly for the form y equals mx + b does not have any parentheses, so first I will distribute the 4. Leave y minus 6 alone, so y minus 6 equals 4x plus, and then 4 times 8 is 32. Now again, we're trying to make it look like that. In this form, y is by itself, so the minus 6 needs to go here by doing the opposite, so by plussing it. Y equals 4x plus 38. If you were ever asked what the y-intercept of this line is, you could say that it is 0, 38, because that's your b. Now here's the last example for this section. Write an equation for a line that passes through 2 points. The first point has coordinates 6, negative 1, and the second point has coordinates negative 4, 79. In point-slope form, y minus y1 equals mx minus x1. Now, hopefully we recall from the previous question that to write the equation in point-slope form, we need two things. We need a point for x1 and y1. That will be the point. And that is given to us. You have, in fact, 2 points that are provided to you. One is 6, negative 1, and another one is negative 4, 79. So the point is not a problem. The problem is we're not given m, which is the slope, and we have to have the slope to write this equation. Well, good news is we can actually find the slope if we have 2 points, and we have our 2 points, the yellow and the blue. To find the slope m using 2 given points, we will use the slope formula. M equals y2 minus y1 over x2 minus x1. Now, this is a good formula to remember. It's called the slope formula. What do the y2 and y1 and x2 and xy represent? Well, they simply represent the y of the second point, the y of the first point, and then the x of the second point and the x of the first point. So your 6, which is the first yellow number, is your x1. That's the x of the first point, and then y1 is your negative 1, and then you have your x2, which is negative 4, and y2, which is 79. So all that's left is to replace all of the letters with the numbers in the formula. M equals, so on the top, y2, that's 79, minus, the formula says minus, so I'm going to repeat that minus, and then my y1 is negative 1. Now, the story with the signs is similar here as before. The formula has a negative, and 1 has its own negative here, so be sure to not lose that negative that belongs to the 1 and the negative that is from the formula. At the bottom, we have x2, which is negative 4, minus x1, which that one is a regular 6. So you repeat minus from the formula, but 6 does not have its own minus. So you got 79 plus 1 on the top and negative 4 minus 6 in the denominator. That's 80 divided by negative 10, which is negative 8. And that finds us the slope, which goes here. Okay. Now we're ready to write the equation. I will be replacing m with negative 8. I will also be replacing y1 right here with negative 1 and x1 right here with 6. So here we go. Y minus your y1, which is negative 1. Again, minus is from the formula, and then another minus that belongs to the 1. Make sure you have both of those. Then equals your m, which is negative 8, and then x minus your x1 is 6. Go ahead and write y plus 1. It just looks cleaner. Negative 8, x minus 6. That's it. You're done. Some questions may ask you for 2 versions of point slope form. What that means is instead of replacing x1 with 6 and y1 with negative 1, you could use the blue point and replace x1 with negative 4 and y1 with 72. that would be another version of this equation. So I'm going to go ahead and write it here just so we have that and we know that that's an option. So y minus y1. Now I know I kind of have y2 here, but it's still the point from the same line, so you can use 72 still. So minus 79 equals m, same slope, -8 that we just found, and then x minus -4, and then we'll clean it up to y minus 79 equals -8 x plus 4. And that's it.